What up? Let's do the homework, okay? Uh, Variables on both sides of the equation. What we got to do is eliminate them on one side so that they remain on the other side. It's not same side combined. It's like eliminate so they remain. You can't just take 3 and add it to 5 and say you have 8x's. That'd actually be breaking it. You'd be like subtracting 3 from here and adding 3 from here. That's not the same thing on the equation. You have to keep the equation balanced. So we eliminate so that they remain. And now we have just a simple two-step equation. Okay. Um, I'm okay. Look at right off the bat. I'm okay having variables on either side of the equation. What I like to do is kind of think about how many variables on one side, how many variables on the other side. I always like to end up with positive amounts. It's just one less thing to worry about. If I eliminated them from the right side, I'd end up with negative ones on the left side. And that's fine. It's fine. But it's just like, man, not having negatives is one less thing to worry about. So this is why I'm going to eliminate them from this side so that they remain on this side. Because they'll be positives. And then I don't have to worry about negatives. Okay. What's bothering the x? The x is over here. The x is over here. 2 times x plus 6. Get rid of the 6, then get rid of the 2. Undo what's being done. Add the opposite, divide or multiply. It's okay to leave it like this, guys. X equals 5. Math is universal. You can read it from right to left or left to right. I hate subtraction. My students didn't want to do this, but it's like, man, it's going to help you. I do the same thing here, guys. I know you might not want to, but like, embrace the positive, eliminate the negative. I feel like that's a song. Eliminate that negative. You gotta act nice. I think it's from a movie. I can't think of the movie. Eliminate that negative. If anybody is actually watching this, you know what that movie is? Yo, I'll buy you some chips at the store because it's gonna bog me. Um, Teachers get half price discounts at that Decamart, so that's sweet. Um, I move the x's over here. I eliminate it from here. They remain on the right side. Okay. Don't worry about this 2. This 2's not bothering anything. Here's the wall. The 10's bothering the x. The 3 is what's doing that. The 3's multiplied by the x. 10 is adding. Undo by doing the opposite. Oh, I know the answer. I know the answer. I'm sorry. You can skip this if you don't care. I'm sorry it's taking so long, but I gotta figure it out. Sorry. I can't find the scene. 2/3 is more than a half. I know what movie it's from. Nobody's gonna know the movie. It's from Mighty Ducks. It's the scene where they skate in the professional hockey rink? I'm almost certain of it. I gotta find it though. All right. I have 1/6 of a C. I have to have a common denominator, same types of pizza slices. So I have 1/6 of a C left, but on the left side. Undo what's happening to the variable. Which side's the variable on? This side. Don't worry about that 5. Don't worry about that 5. Very much like the problems we did in the notes. Similar stuff here. I'm going to eliminate the ones on the left because 5/6 is more than 2/3. 2/3 in pizza, 5/6 in pizza. But to add 5/6 and -2/3, I need to change the -2/3 into sixths so that they're similar pizza slices. 1/6 again. This is the same thing as our notes. Plus a negative. Keep track of your wall. Add 11 to both sides. Multiply by 6 or divide by 6. But when you divide by 6, it's the same. I don't think I changed this from the notes. My bad. 72. Maybe it's different. Oh, look at me. I made sure I put these in here. Why did I put these in here? Because if you're stuck in the world of put variables on one side, this is what would happen to you. This is what happens to so many of you. You have 6, you have -5x, and then you're like, I guess it's that. And I guess I divide. Nope, you're wrong. You're wrong. If you put your variables on this side, watch. You have 0 left on that side. Here is your wall. You've eliminated everything from this side of the wall. What remains on the wall? 0, but you have to show it. You have to keep the equal sign where it is. And like if you have blank space here, that's your indication. It's 0. So actually, again, sometimes, and this is the situation where I'm actually okay if there's negatives. If there's just variables on one side, let's just put the rest of the variables on the other side by eliminating so that they remain over there. And then we realize the answer is positive. Okay. Like this one. I would get rid of the 3 R's here so that I don't make that mistake of forgetting about the 0. 4 equals -1R. That's simple. So, like, don't be afraid to do something new. Don't be afraid to try something new. Don't be formulaic. You guys are now like juniors, sophomores, juniors, seniors. Don't be formulaic. Start over, okay? It's okay. You're now old enough to really understand kind of what's going on. You're understanding the puzzle that we have. And we're honestly just thinking about computers, like steps to solve situations, to get answers. This is good thoughts. So, like here, don't be afraid to add 3/4 of an x to both sides because 3/4 minus a quarter, I have 3/4, I owe a quarter, I have 2/4. That's like easier. That's positive. That's 1/2 instead of having -1/2, which is annoying. Here are my x's on this side of my wall. Undo what's being done. Save the princess. Divide by 1/2, same as multiplying by 2. Okay. Well, this one's tricky. Or it's not. You can kind of see it's got to be 0. Can't be any other number. I gave you a lot of work to do. This is just like making sure we are able to handle any type of problem. It's okay if we don't do everything. Like my students in my class, it's okay if they don't do everything. I might go a little bit faster though through these so we can get to the tricky ones. 4/2 is the same as 2. Minus a half is 3/2. Divide by 3/2. Multiply by 2/3. Same side combine. That's something new. Okay. We did this last class. Same side combining. Same side combining is what you do if we're talking about on one side of the equation. Okay. So on one side of the equation, on one balancing slab, I owe 3 B's and I have 2 B's. I net owing 1. That's it. We do not add 3B like this. We do not do that because that would be putting 6 B's on that side of the equation. And that would totally unbalance things. It'd be heavier over there and you'd break the equation. So don't do that. You got to keep things balanced. Things that are done has to be on both sides of the equation. Oof, I had this one in the notes too. Lots of negatives, like -1 times 1, -1. A -1 here. A -1 times a -1B. Positive 1B. Same side combined on that side. I owe 1 and I owe another 1. I owe 2. Divide by 2, divide by 2. 1/2. Negative. Oh, brother. Oh, it's not that bad. When I distribute, sometimes distribution will help simplify. Instead of trying to like get rid of it first, like dividing, distribution. And then same side combined. 4 times 1/4 is 4/4. 4/4 is 1. 4 times -2. -8. 3 times 1/3. 3/1 times 1/3 is 1. Ooh, I made a mistake here. I probably didn't intend for this to happen. I intended for this to happen here, where we have to be careful of anything or nothing at all. Same side combine. Ooh, I have a situation where after eliminating Q's from one side, there's just no Q's left at all. This is a situation where be careful. Sometimes when you start with variables on both sides of your equation, you could first of all start with like not an equation. This is not an equation. It is not balanced, and nothing Q can be can make it balanced. Nothing. No solution. Q can't be anything. The equation is unbalanced and will never be balanced. Okay? Sometimes the equation will always be perfectly balanced no matter what our value of our variable is. It can be anything. Here's an example of nothing. How do we know it's nothing? If you eliminate your variables and you end up with a false statement, -2 equals 3. No, that's not true. Like, that's not true. So Q can't be anything. It'll never be balanced. There's always going to be more on one side and less on the other side. I don't think that'll happen here. I think it was a mistake in whoever made the homework that it showed up a little bit early. But if we were there for the notes, we were good for it. Same, oh, close. Same side combine. Same side combine. This is a good one. This is a good one to see. Sometimes answers will be zero. Maybe let's do it your way. I say it your way because like a lot of teachers teach it this way. Let's do it a lot of teachers' ways, getting the variables on one side. Okay, negative 3t equals 0. This doesn't mean no solution. If you divide 0 by 3, you get 0. An answer is 0. 0 is a number. It has feelings too. Don't disrespect it and say, oh, we don't have any solution. It's like 0 is a solution. 0 is the only number that would balance this out. Versus this one, there are no numbers that would be balanced, that would balance this out, including 0. Okay, and we'll see more of those where we are either perfectly balanced or not balanced at all. Same side, combine. I have 2, I owe 3, I net owing 1. I have 3, I owe 2, I net having 1. Same side, no matter what x is, you're just going to add 1 to it after you take the opposite of it. Just always going to work out, no matter what. Because of the way this was oriented, we realized it's just like, yo, this is perfectly balanced no matter what. So, anything. Be anything. Pick a number, plug it in, it'll work. Pick any number, plug it in, it'll work. Pick a decimal, plug it in, it'll work. This is a symbol for any real number, any decimal. That's a symbol for. Let's see this. I like to distribute, but I like to make things plus and negative. Negative 2 times negative 1, positive 2x. Same side of the wall, combine. I have 2 x's, I have 3 x's, I have 5 x's. I owe 8 apples, oranges, whatever I call them. I owe 8, I have 7, I net down 1. I still owe 1. I have same side combined. Oh, yo, this one, it's not going to be an all or nothing. This is a fake out. I apologize if I'm going too fast here. However, um, your teacher should have told you. You should have gone through a lot of these in class, and then hopefully these are just like the extra ones that you didn't get to. 0 is a number. It has feelings too. That's the solution. Here's my wall. Same side of the wall combined. I owe 2 x's. I have 5 x's. I net 3 x's. I have 1. I owe 5. I net owing 4. Same thing on both sides. The x's would go away. We'd have negative 4 equals negative 4. It's just true. No matter what x would be, we will always be balanced. X can be anything. Let's see what happens here. I'm going to distribute. Distribute. Same side combined. Yeah, it's another fake out. This is not an all or nothing. Hold on. I feel like I made a mistake here, guys. No, I thought I did a plus minus. It's so tricky with this stuff, but I'm taking away this, so it's like you're adding the opposite. You're distributing. It is negative 3x and negative 1x. Same side combined. I owe 3 and I owe 1 x's on this side. I owe 4 x's. I'm going to add the 4 x's to both sides, eliminate them from the right side so they remain on the other side, because then I have positive. So I'm not always going to put stuff on the right side. Just depends on the situation. Divide both sides by 3. X is negative 1/3. Fraction, that's okay. Definitely not a question that you would have been able to get yourself. All right, 4 more. Let's power through these. Looks like the Y's are going to go away, but they're not. And we get a crazy fraction answer. That's okay. It's okay. Same side combine, same side combine, same side combine. Ooh, I see what I did here. No, should have done that. Sorry. Add the two x's, so I have positive two x's on this side. Positive two x's plus the one x, so I have positive one x's on this side. Keep everything else the same though. What I did here is make it so that 0 is our answer. I feel like I have a lot of these, but that's okay. This is good. It looks like it's the same thing, right? Doesn't it look like 3x minus 15, 15 minus 3x? This is where subtraction deceives us. Like, this is not the same thing. 5 minus 2 is not the same thing as 2 minus 5. 5 minus 2 is the same as 2 plus negative 5. Or, sorry, 5 plus negative 2 is the same as negative 2 plus 5. But, 5 minus 2 is 3. 2 minus 5 is negative 3. They're not the same. You got to add the opposite so that way it's like, oh, yeah, it's just negative 2 plus 5, or 5 plus negative 2, 3. So, like, these aren't the same. And you can see if you eliminate some to leave them on the other side, solve the multi-step equation, where's x, isolate it, you get 5. You get 0 equals 0, but when you plug in 5. Last one. Same side combine. Let's remove them from here so that they're positive. And you're good. All right, that's the homework video. Hope we're good. Unit 1 test coming up. Challenging you to do it without a calculator. All right, but it's fair and it's review. We're doing more review. We're doing like graphing linear equations. Hopefully, it'll help us understand how to graph. And we'll go from there. Later.